Now, this is our most important section, section C. We'll now solve for ax squared plus bx plus c equals to 0. And remember that a cannot be 0, or else this will become a linear equation. Before we start, I first want to point out that previously we have been working on the distributive property to go from the left side of this example to the right side of this example. Now we're doing the reverse. This is factoring. From the right side, we're trying to find the two things on the left. It will be a bit more challenging than the distributive property, but in time, you should get used to this situation. Now, ax squared plus bx plus c equals 0 can either have 0, 1, or 2 solutions. Now, why is that the case? We'll explain it here. So if you remember in the introduction section how a ax squared plus bx plus c curve might look like, it could either look like this or something like this. Regardless of whether it is concave up or down, we're simply looking at when that sort of curve touches the x-axis, as this will be when ax squared plus bx plus c equals to 0. So when there are 0 solutions, it simply means the curve doesn't even touch the x-axis. So something that looks like this will have 0 solutions because there is simply no contact point between the function and the x-axis. Now how about 1 solution? Similarly, this would just mean that a given curve of any sort for ax squared plus bx plus c will only have 1 contact point with the x-axis, such as drawn below. That 1 contact point being somewhere around there. And we can also have 2 solutions, which is the maximum amount of solutions you should be able to find from a quadratic equation. It should look something like this. As we can see, there are 2 contact points, meaning that there are 2 solutions for x. Now, given that we don't have situation 1 with 0 solutions, aka ax squared plus bx plus c equals 0, can indeed be factored. We can find the 2 factors for situation 2 and 3, no matter the case. So the general idea is that we first have to make sure our given equation actually looks like ax squared plus bx plus c equals to 0. So for example, if I have perhaps 4x squared plus 3x plus 1 equals to 2, that is not okay. I need to first subtract 2 on both sides in order to make my quadratic look like this. This is now a possible situation for you to solve using the methods we'll talk about later. And again, I must emphasize that for now, we're only talking about situations that can actually be factored. We'll discuss situations when we cannot factor and how to identify such situations before trying to factor something in later lessons. Furthermore, if I have something like this, this is a different type of form. In fact, this is called the vertex form. However, if you want to use the methods that we're discussing in this chapter, you first have to expand the term in a bracket so that there is no longer a squared over x minus 2, and instead it is in the expanded form. And then you must simplify so that we only have ax squared plus bx plus c equals to 0. So doing something similar to what I'm doing now, x squared minus 4x plus 4 plus 3 equals to 0. That's step 1, me expanding the bracket. Step 2 is to simply simplify, combining my like terms to give me this. Now I can try to use the methods I'll soon teach you guys on this quadratic equation. Now, the second step is optional, but you should do it if possible, to reduce the chance of mistakes due to larger numbers, and to simply make math a bit easier in these type of situations. So again, if possible, find the GCF between the three terms ax squared plus bx plus c equals 0. Here I have a situation 3x squared plus 6x plus 9 equals 0. We can see that all three of these terms have a factor of 3. So we can simply divide 3 on both sides to simplify it into this, which is much more easier to solve. Step 3 is to obviously just factor for ax squared plus bx plus c. And step 4, we use the zero product rule we talked about before and solve for x. So this is the first method we'll use to factor a quadratic equation. This is called the grouping method. Essentially, we have to find numbers that when multiplied together make a times c in ax squared plus bx plus c. And when we add those two numbers together, we get b. So let's use an example to talk about this. For example, 2x squared minus 3x plus 1 equals to 0. Now step 1, let's review. We have to make sure the equation looks like this, and it does. Now step 2, we have to find the greatest common factor if possible, and then factor it out. That is not necessary because our given equation is already simplified to the maximum degree. And then step 3, we have to factor x squared plus bx plus c using the grouping method as one possibility. So we have to find two numbers that when multiplied together equals to a times c. Let's first identify what a, b, and c are. This is my a, this is my b, and this is my c. Apologies, I should have included a negative sign. So, what is a times c? In this case, it is 2 times 1, giving me 2. What is b? B is negative 3. I'll make a note here that it is very important for you to include the negative sign as part of a, b, or c in order to maintain accuracy of your answer. Now, what two numbers multiplied together make 2 and added together make negative 3? A simple way to do this is to simply look at the factors of 2, or AC. The two numbers that can be multiplied together to make 2 are either 2 and 1, or negative 2 times negative 1. Since they have to add together to make negative 3, we'll look at this, as this clearly works. Now, we found our two numbers, negative 2 and negative 1. What do we do with it? We simply break down the middle term, bx, into two terms now. One with negative 2 and one with negative 1. So what do I mean? Let me just demonstrate it by writing it out. So this is my first term, using the first number I discovered for this situation. This is my second term, negative 1. All else remains the same. Now that I have this, I can do some more factoring by finding the greatest common factor between the first two terms and see if there's any greatest common factor for the second two terms, depending on my type of problem. In this case, however, I'll just investigate the first term first, as the second term looks fairly simple already. So I can see that the first two terms share 2x in common. So I'll just simply pull 2x out in the front, writing all that I have left inside. Now, our second two terms are negative 1x plus 1. It looks like the exact opposite of x minus 1. If we just multiply perhaps negative 1 to both terms in x minus 1, we can transform it to negative x plus 1. So let's do that. But wait, I can't just simply do something and expect it to not affect the values of other terms. So there's this trick. Let's pretend I am multiplying two negative ones to 2x, x minus 1, keeping the rest the same. So why am I multiplying two negative ones? Because this inherently means I'm just multiplying a positive 1. And we know that 1 does not change the value of anything it is multiplied to. Since it is inherently not affecting anything about the true value of this situation, I can simply use one of the negative ones to change my factor x minus 1 into something that looks like this. So I'm going to do that. Negative 1, 2x, negative x plus 1. Switching the signs here because I multiplied both items in the bracket with negative 1. And again, keeping the other side exactly the same. Now, note how I now have two identical terms. Negative x plus 1 and negative x plus 1. So we can factor once more. In this case, we can simply pull the term negative x plus 1 to the front, leaving negative 2x with the first term and a simple 1 to the second term. So we now have two clear, distinct terms, negative x plus 1 and negative 2x plus 1 equals 0. We can now apply the zero product rule. So let's do that. X plus 1 equals 0 and negative 2x plus 1 equals 0. If I simplify the left side and solve for x, I'll have x equals to 1. If I simplify the right side to solve for x equals to 1 half. And there are our two solutions for x, when ax squared plus bx plus c equals to 0. Now, before ending this lesson, I want to talk about some special situations that you may encounter that you do not have to actually try to solve using the methods we described before. There are actually quicker ways to solve for these special situations. So for example, if you encounter anything that looks like a difference of squares, which is m squared minus n squared, you know automatically that your factors are m plus n multiplied by m minus n. Similarly, if I ever see a situation that looks like this, m squared plus 2mn plus n squared, I know that this is just m plus n squared. So take a look at this first situation I've written here. We have x squared minus 25 equals to 0. This looks exactly like how I expect a difference of squares to look like. So I changed it to 5 squared so that it's easier to view. Now, I found my two terms, m and n as well. M being just x, and n being 5. So I placed it in its appropriate locations in the formula. And this, in 3 steps, I've quickly found my values for x when this quadratic equation equals to 0. In the second situation I have, where x squared plus 2x plus 1 equals to 0, I can see that this is just one of the most basic forms for a perfect square. To help you guys see, I've identified m and n. M is just 1x and n is 1. To to simply apply the sum formula on top of this situation, I can find that I have this, which is then equal to 0. Notice how x plus 1 occurs twice, which is why there's a square on top of x plus 1. If I break it down to each term, I'll have 2 terms of x plus 1. Since I know that x plus 1 is the same as x plus 1, I only have to solve once. Since I found what x plus 1 equals 0 is, it's just when x equals to negative 1, there is only going to be one solution to this situation. Or if you think about it, it can also be 2 identical solutions to this situation.